So right now you are checking your answers. Some of them have more than one answer, so just keep in mind that some of the questions have more than one answer. The way this works is that you check your answers, you circle the ones you got wrong, and hopefully you ask me about it, or you ask a friend about it, or you realize right away, oh, I know what I did wrong. Okay? Good question. Is segment CB the same as segment BC? Does order matter when you're naming a segment or a line? Nope, it doesn't matter at all. It's a collection of points. So the collection of points from B to C is the same collection of points from C to B. So the order does not matter. The order does not matter. That's good news. You can't mess it up, right? Can't mess up the order. Let's start by going over 16, 17, and 18. So I'm going to number 16. Oh, is this the wrong homework? Ready? 16, 17, and 18. Okay. 16 says A, B, C, and F are coplanar. Remember, coplanar means I could put a plane through all four of those points. Let's take a look at where they are. A, is it going to let me write? Oh, it doesn't let me write. Okay. A, B, C, and F. Are all of those in the same plane? Trying to find where my icon is where I can write on it. Transparency layer. There it is. Okay, cool. A, B, C, and F. Notice A, B, and C are all in that plane that was drawn for you. So that plane is locked in now. It can't tilt. It cannot move at all. So how are we going to grab F and be in that same plane? We're not able to do that. So those 4 points are not coplanar. That is false. They are not coplanar. All right, 17. B, C, D, and E are coplanar. What is the difference between what we just asked in 16 and what we're asking in 17? Because there's a big difference. What do you notice about B, C, and D? They're collinear. Since they're collinear, my plane is now allowed to tilt. We are not locked into that plane with point A. The plane that's drawn, we are not locked into that plane. So I could draw a plane. Let me show you the plane. I could draw a plane that captures all of those points. There's a plane right there, and I just captured all 4 of those. So those are coplanar. Was the plane drawn? No. Could you draw a plane? Yes. So coplanar means I could draw a plane, not it's already drawn for me. Okay, 18. A, B, and F are non-coplanar. Let me give you a hint, guys. Any 3 points in the universe are coplanar. Let me say that again. Any 3 points are coplanar. I could put a plane through any 3 points, just like I could put a line through any 2 points. So I don't even need a picture for this. I don't need a picture. It's gone. I'm going to say false no matter what, because A, B, and F are coplanar. Because any 3 points are coplanar. Did I get my point across? Okay. Can't remember what was next. So then the last one was just the last problem, right? And like I said, I'm not sure I'm going to be able to describe this any better than they already did. Planes A and B intersect and planes B and C intersect, but planes A and C do not intersect. I don't know where that one went. Okay. Let me remind you about two planes. If I have two planes and they don't intersect, what is their only choice? Their only choice, if two planes do not intersect, they must be blank. They must be parallel. Because planes can't be skew. So if they don't intersect, they must be parallel. Planes can't be skew, it doesn't work because they go in all directions. So the first thing I would have done on that problem is draw those two planes and draw them parallel. And then it's really easy to figure out how to draw the last one. It has to intersect them both. So that last one, you just draw straight across, intersecting both of them. Okay, let's move on. If you like to take notes, we are taking notes. I don't have a little notes page for you anymore. You would just take notes on your own in your binder, in your notebook, wherever you want to take notes. And you can title it Segments and Rays. We're just going to expand a little bit more on segments and rays. Oh, I love notes. Oh, good. Me too. Okay. So, I want you to take a look at this very, very simple picture. What is the relationship between, what is that? Ray ML and Ray MR. Good. They have a common point. Someone said they intersected M. They share a common point, and that's M. That's good. They don't have a midpoint. You can't have a midpoint unless you're a segment. Lines can't have midpoints. Why can't a line have a midpoint? No, that's okay. No, it brought up a good point. Why can't lines have a midpoint? Because they're infinite. How do you find the middle of infinity? Whoa, think about that tonight. Ponder that. Okay. What about the direction of Ray ML and Ray MR? What about their direction? Same direction? One goes left and one goes right, opposite. That was the word I was looking for. Yay! These are called Ray ML, and Ray MR are called opposite rays. They're called opposite rays. Two collinear rays, because they're all on the same line. They have the same end point, but they go in opposite directions. So two opposite rays always form a line. Oh, good. You found mics that work. Good. So in this example, ray YX is an opposite ray with ray YZ. Now, when we were going over the homework, I was saying that when you're naming a line or a segment, order doesn't matter. It doesn't matter which letter you put first. But when you're naming a ray, order matters. You always name a ray beginning with the end point. So I named both of those beginning with Y, because Y was my end point right there. Okay, just for fun, name some times in a day when the hands of a clock are opposite rays. You probably don't stare at clocks like this much anymore because you have cell phones and digital watches and stuff, but 12:30, I heard 12:30, I heard 6 o'clock. That's cheating because it's already 6 o'clock on there. So definitely 6 o'clock. Someone said 12:30. Does anyone want to argue 12:30? Some of you are saying correct answers. I see you. Does anyone want to argue 12:30? When it's 12:30, I agree that the minute hand is right here, but the hour hand would be halfway between 12 and 1 because the hour hand creeps over as time goes by. So 12:30, they would not be opposite rays. I don't have any other for sure answers. I don't. They're kind of all just guesses. But yeah, I was just trying to, the fact that to be opposite rays, they need to form a perfectly straight line. So thinking about what times it forms a perfectly straight line was just for fun. Okay. Name two pairs of opposite rays. So, I mean, this is really straightforward. All you have to do to name two pairs of opposite rays is choose your endpoint. Now, what I did want to talk about on this slide was if I'm going to name this ray and this ray, this first one is obvious. That one's obvious. But what do I name the one going to the right? Do I name it ray BC or do I name it ray BD? And are those the same ray or are those different rays? Ooh, we can't use three letters because when we use three letters, it's a plane. Remember? Two letters make a line, three letters make a plane. So BC, ray BC, and ray BD are the same exact ray. These are the same ray. There is no difference. So you couldn't use either one. Either one. Okay? Okay. All right, we're going to do a little true-false. You ready? True or false? We have a different figure here. It's not a rectangular prism this time. Okay, segment AB and segment HG are coplanar. True or false? I hear people saying false, so I'm going to click false and see if we get a ding. If we get a ding, it's correct, and if we get a it's wrong. Okay, ready? Maybe my sound isn't working. Oh, y'all totally couldn't hear it, but it dinged, I promise. Ding, 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 ding. It is false. They are non-coplanar. What are they? What word are they? You don't have to write any of this down. We're just learning. It's notes. I would not spend time drawing that picture. They're skew. Very good. And by definition, skew lines are non-coplanar to begin with. Next one. IJ and AF are skew. True or false? IJ and AF. Let me click false and see what happens. Did y'all hear the buzz? Probably not. That's wrong. It is true. Someone might say, but wait a minute, Miss Tanton, those two pink lines, those are intersecting. But you need to remember that that's a 3D figure. And that IJ in the way back is not hitting the AF coming in the front. There's space between them. So they are skew. There's depth. Yes, I like that. Good. ED and IG are coplanar. ED and IG. Those aren't in the same plane. One's in the front and one's in the back. And what are those? What are those? Are they skew? Are they, what's the word? They're parallel. And by definition, the first word in the definition of parallel is coplanar lines that never intersect. So they are definitely coplanar. Even though they look like they're in separate planes, they're definitely coplanar because they're parallel. There's the plane right there. True. Just because one's in the front and one's in the back doesn't mean you couldn't put a plane through them. Parallel lines are always coplanar. Okay. Last one. I, H, and C are coplanar. I, H, and C are coplanar. No one's freaking out that I deleted it, did you? I usually delete it and my class freaks out. They're like, I can't solve this. You got rid of the picture. But I did talk about this earlier. You don't need a picture. If I ask you if 3 points are coplanar, I don't care which 3 points I name. It could be any 3 points in the universe. You're going to say true every time, because any 3 points are coplanar. You don't need a picture. Now, normally I would say get out your whiteboards. If y'all have dry erase boards, you could, or you can just solve these on paper. The only thing is, unless, here we go. EB is parallel to what segment? You are not typing it in the chat. I'm going to call on some of you. I might not know how to say your name yet. Alton. Alton from Truett. What is your answer? EB is parallel to, let's try again. Do you see it now? You don't have to write the question on paper. This is just practice. It does not have to go home with you. So the answer is capital H, capital C with a segment on top. We okay? Let's keep going. Name the intersection of segment EB and segment BD. Name the intersection of segment EB and segment BD. V from Kayla. I am calling on you. V from Kayla. Yeah! We know that when two lines intersect, you get a point. And what point do they intersect at? They intersect at point B. So your answer should have been one capital letter B, and that's it. No symbols or anything, okay? Okay. Next one. How many lines contain point B? How many lines contain point B? Relena from Aragon. I hope I said it right. Correct me if I didn't. Okay, Relena. What do you think? So that's the catch to this. There's one line that contains point B in my picture, but how many lines exist that contain point B? It's our favorite word. Someone brought up a really good point. Someone put the word all in the chat. Do all lines contain point B? Is saying all the same as saying infinite? No. All lines do not contain point B, but an infinite number of lines contain point B. There is a difference. Careful. Okay. Next one. How many lines contain point A and point B? Let's do Johan from Goodson. Johan? Probably. Yes! One is correct. There's only one line that contains both of these points. Remember, it takes 2 points to make a line. So there's only one. List 3 points that determine plane K. 3 points that determine plane K. Let's do Yoon from Truett. Johan. Okay, D, C, B. Very good, that'll work. D, C, B. The only thing that we have to be careful about, I don't know if that's Han or Han. Well, Hans, Johan, that's what I said the first time. Oh, there's no sound. Anyways, okay, so the only thing we have to be careful about is if we're going to determine plane K, we can't just name any 3 points. We have to make sure they're non-collinear points. So could you have answered FAB? F, A, B, those points determine plane K. No, because you can't name collinear points. And I want you to think of a tripod. If I took the legs of a tripod and I put them all in a row, it would fall over. So you can't pick 3 points all in a row, but other than that, you can pick any 3 points. Name 2 points that determine line L. Let's do Araceli from Watkins. I'm putting you on the spot. You're new. Sorry. DBC would work. DB, sure, yes. I didn't give you a tough one. 2 points that determine line L. Italicized L. Yep. Make sure they're capital, because when we name a point, they're capital. So you'll want to watch any lessons that you missed, because we talked about how when we name a point, they're capital letters. So we're just naming 2 points that are on line L. Very good. How many planes contain segment FB? Chloe from Aragon. Try again. Now there are 2 planes that are drawn. There are 2 planes drawn that contain FB. But how many planes? Yeah, infinite. Ugh, that word again. Yep. It's haunting us. Oops. Name the intersection of line L and segment FB. This one's easy. Let's do Victor from Cook. Yep, you were ready. A. That's where they cross. Very good. All right, now on your whiteboards or on your paper, I want you to draw 3 non-collinear points. I can't pick you because you can't draw in the chat. How do you say your name? Is it Abhi? Abby? Abhi? These 3 points are coplanar, check, but they don't determine a plane because they're in a row. So that's the difference. This right here is impossible. You can't do this. You can't draw 3 points that are non-coplanar. You can't do it. Impossible. Draw 4 points that are non-coplanar. Now this one you can do. So you can draw yourself a little plane and then put one away from it. That would work. Okay? Unless one is in another universe, you can still get to it. This point is non-coplanar with these 3 points. Oh, we're done. Look at that. Point, line, plane practice is your homework.